For problem number 1, it says that Miss B's age is 6 years more than 4 times her son's age, and 3 years ago she was 7 times as old as her son was then. So they give us the variables. B is Miss B, and S is her son. So we need to write a system. So I'll start with the present time. So I'll say now, Miss B is B, and she is 6 years more than 4 times her son's age. So we're going to say she is 4 times her son's age plus 6. And then I'll go to then. And then was 3 years ago. So she was Mrs. B now minus 3. And it says she was 7 times as old as her son was then. Well, S represents her son's age now. So now her son is S minus 3 would be then. And she's 7 times as much as that. So I need to leave room for that. 7 times as much as her son was then. So those are 2 systems of equations. Now it says determine algebraically. So we would need to decide what we want to use. So I'm going to say that I'm going to use substitution because 1 is already solved for B. So we will have that we know B is 4s minus 6. So I would say, okay, so we'll use the second equation. So B minus 3 equals 7 times S minus 3. But I'll replace that B with my 4s minus 6. So I'll just show that. So I'll say B used to be there. Instead, so I'll bring down this 4s plus 6. So I have my 4s plus 6. Just highlight that in red so you can see that's what replaced the B. And now we combine like terms. So you'll have 4s plus 3 equals 7s minus 21. And you'll bring your 4s's over. So you have 3 equals 3s minus 21. Add your 21 to both sides. You'll end up with 24 equals 3s. So you divide and you'll have s equals 8. So her son is 8 years old. And then we want to know the ages of her and her son. So now we're going to substitute back in. So Miss B is equal to 4 times her son, which is 8, plus 6. So Miss B equals 32 plus 6, or 38. So son is 8 years old. She is 38 years old. And it says, how many years from now will she be 3 times as old as her son will be then? So for this, we want to say let x equal the number of years, because that's what we're looking for. So let x equal years. You could say y. And in a certain number of years, she's going to be 38 plus however many years have passed. And we want her son, he'll also be 8 plus however many years have passed. But we want her, this side, her 38 plus x, to be 3 times however old he is. So there's our system. I put the extras in red. And now we would solve this system. So it's really just an equation, not a system. So you end up with 38 plus x equals 24 plus 3x. And when you solve this, you'll subtract 1x. Remember, this is a 1. So you can loop around and say 38 equals 24 plus 2x. Subtract your 24 from both sides, and you end up with 14 equals 2x. So we'll divide both sides by 2. X equals 7. So in 7 years, they will be the same. So she will be 3 times as old as her son will be then. Let's look at the next one. That one's a tricky one. Alicia purchased H half gallons of ice cream for $3.50 each, and P packages of ice cream for $2.25 or $2.50 each. She purchased 14 items and spent $43. So that the red sentence underlined is your first equation. So let's check down at the bottom. So $3.50 for half gallons and $2.50 for ice cream, and it says she purchased 14 items and spent $43. So which one needs to include the money would be the one that includes your $3.50 and $2.50. So we are looking for the $3.50 for the half gallon and the $2.50 for the packages of ice cream cones to add up to 43. That means we need to rule out question choice 3 and 4. She purchased 14 items. So which equation could be used? So here we have 350H and 250P would be our choice number 1, and that lines up correctly. The second one, they gave the P the 350, and we want it to be 250, so it's got to be choice 1. Okay, our next one. Which system of equations does not have the same solution as the system below? So you have a variety of ways you can solve this. You could go ahead and solve each system, or you could kind of look for some clues to let you know what's happening. You can use your calculator to do the end solve to figure out exactly the solution, but let's think efficiently. So if I multiply the top equation by -3 and the bottom one by -2, I will end up with system number 1, and those variables would cancel out, so that is going to have the same solution. So that one we can rule out. And if we look at the bottom one, for number 2, we would be multiplying the top by 5 and the bottom by 3, and we would end up with 2. So that's just a manipulation of that one, so we can rule this one out as well. And if you look at choice 3, you can see that it's just the same system multiplied by 6 and 4. So the one that will not work, if you take a look at this one, the choice 4, the top one, you can multiply by 10, but then the bottom one, you can't multiply by anything to get this to happen, because notice on the left-hand side it turns positive. So those go to positive and this one stays negative. So the only way that would happen is if you multiply by a negative and for the left, but then the right turns positive. So it has to be choice 4. There's nothing you can do to manipulate that equation. Okay, for problem number 4, it says Zeke and 6 of his friends are going to a baseball game. So right now, make sure you realize that there are 7 people at this baseball game. You're counting Zeke plus 6 of his friends. Their combined money totals $28.50. So all 7 of them together spend $28.50. And at the game, hot dogs cost $1.25 each, hamburgers cost $2.50 each, and sodas are 50 cents each. This is another key piece. Each person buys 1 soda. So let's go ahead and say, okay, 7 times 50 cents. We know they're spending $3.50 on soda. So that is not a third variable. So they all spend $28.50 on food and soda, which means they're using up every smidge of the money they have. So they give you the variables, hot dogs X and hamburgers Y, and you would say, okay, so they're spending $1.25 on hot dogs, and they are spending $2.50 on burgers, and they already spent $3.50 on soda, and that all totals $28.50. You could clean this up a little bit by moving your $3.50 to the other side, or never including it in the first place and just writing this equation, $1.25x plus $2.50y equals 25. Okay, dropping off your decimals, that's totally okay. And then you don't know how many hamburgers and hot dogs they have. You would need to graph this. We're not going to do this as part of this problem, but you would graph it. You could solve this for y equals mx plus b. You could put it into your calculator and then transfer it. But all your different combinations of burgers and hot dogs would be on this line. So any one of these would work. It's not an inequality, but it is a spot where each one, you've got your hot dogs are your x and your burgers are your y. So there could be a whole bunch of different combos that will work to give you $28.50. The sodas are fixed. Everyone buys 1. Okay, the next one. In attempting to solve this system of equations, John graphed the 2 on his graphing calculator. Because he saw only 1 line, he said it was an empty set or no solution. Remember, that just means no solution. Is he correct? Explain. So there's a bunch of ways you can think about this. The best is to remember that if they are just 1 line, they land on themselves. So let's say this is equation number 1. Equation number 2 would be graphed right on top of it. And that would mean that there are infinitely many solutions. So infinite solutions is the correct. It says explain your answer, so you're going to need to do some writing and say that they are the same line. That means they land on each other. You can also prove here you've got y equals 3x minus 2, and then you have 6x minus 2y equals 4. So if you divide that entire equation by 2, you end up with 3x minus y equals 2. Solve that for y, and you end up getting the exact same equation, right? Y equals 3x minus 2, so you could prove it that way. Okay, so for this one, a system of equations is given below. Which one does not have the same solution? So you're looking for a mismatch when we multiply by something. So here the top one has been multiplied by 3, and the bottom one, nothing has happened. Here the top one has been multiplied by 4, and the bottom one stays the same. This next one, the top one stays the same, and the bottom one is multiplied by 3. Here, the top one stays the same, and the bottom one, it looks like the first one is multiplied by 2, and then this one is multiplied by 2, but then you have to be consistent, and this one would have had to be multiplied by 3 to get the 12. So it has to be choice 4. Okay, and this one is a repeat, so we can say a go up here. And for problem number 8, they went to the bakery to buy desserts. Franco bought 3 packages of cupcakes and 2 packages of brownies for $19. So let's go ahead and write that system. So I'll say let x equal cupcakes, because I noticed they gave the variables down here. So let x equal cupcakes, and let y equal brownies. So I've got my 3x plus 2y equals 19. And then the second sentence is 2 packages of cupcakes and 4 packages of brownies. So we've got 2x plus 4y equals 24. One thing to notice, it says x is the price of one package and y is the price of one package. So you might be thinking, normally we have dollar signs here, but this is kind of giving us a little bit of an assist by saying it's the price of a package. So we literally can write it as a straight up equation. Now it says graph the system. So in order to graph the system, you have a couple of choices. You can get it into your intercepts, y-intercept form, or you can graph using the intercepts. So notice they give you the x and the y, but they do not give you a scale. So there's the challenge of this problem. You do have a calculator in your hands. You may use the calculator and transfer points. You may use the intercepts method, so I'll just write those down, calc, intercepts, or you can solve for y. So you'll see that I have solved for y, and that's helping me decide what my scale is going to be. So I'm just going to go by ones. And I don't have to label this, but I'm going to, just so you can see that I'm going by ones. And I'll go ahead and I'll graph the first one. So here we have our first equation, negative 3 halves x plus 9.5. Luckily, we're going by halves each time. So we'll start up here. And negative 3 halves is going to take me down 3 and over 2. So 1, 2, 3 over 2. 1, 2, 3 over 2. 1, 2, 3 over 2. And I can go ahead and draw my line down. And I've got my 3x plus 2y equals 19. And then the other one, negative 1/2 x plus 6. So this is going to start here at 6. And I'm going to go down 1 and over 2, down 1 and over 2, down 1 and over 2, and so on. And what is interesting about this problem, my line is not really perfect here. What is interesting about this problem, so I've got my 2x plus 4y equals 24. It now says determine the exact cost of one package and the exact cost of one package of brownies. So they've had you graph, and it says justify your solution. So now you're going to need to go back and use your elimination method to come up with your actual answer for the cost. So they're kind of making you do it by graphing and with elimination. So you can be checking this with your calculator, but it does say justify your solution, so you'll need to show some work. So Sense, and you have your solutions. Your justification is there. And that wraps up the practice. Okay, so I needed another page to do this. So we have 3x plus 2y is 19, 2x plus 4y is 24. So you need your variables to cancel out. The quickest thing for me would be to multiply by -2. So we'd end up with -6x, -4y equals -38. Those are the two equations you want to add together. So we will add and we end up with our -4x. These cancel out, equals -14, and then you would divide both sides by -4, and you got x equals, and you've got 14 divided by 4, and you get 350. So your package of cupcakes per package of cupcakes. To find your package cost for brownies, you plug back into one of your equations. So why don't we pick the top one before you modified it? So we'll say 3 times 350 plus 2y equals 19. So you got 350 times 3. So I'll give you 1050 plus 2y equals 19. Subtract your 1050 from both sides, and you'll end up with 850. So you have 2y equals 850. Divide by 2, and you get y equals $4.25, which is the cost of a package of brownies. And that is your solution.